All right, so we're picking up here 1.6, solving radical equations. So first says, if necessary, isolate one radical to one side of the equation. Then second step, raise both sides of the equation to the power of the index of the radical. Of course, if I scroll up too fast, let me know. Third step, solve the equation. If the radical still exists, then repeat steps 1 and 2. Check the solutions, and you'll see when we go throughout our solving why it's a must in this case that you check the solutions. There's not always, notice I haven't emphasized it in other processes that we've used to solve, but whenever you're solving these radicals, especially when we're talking about taking the power, the even power of both sides, you must check your solutions because of the alteration of the equation, it's a possibility that one of the solutions may not work, even if you did everything correctly. All right. Scroll up. All right, so let's look at the first one. It says the square root of 2x minus 1 plus 2 equal to 0. Equal to 0, equal to x. Sorry about that. All right. So first step is to isolate the radical. We want to get the part that has the radical involved on one side by itself. So the first thing we will do is subtract 2 from both sides. 2's cancel, and that leaves us with the square root of 2x minus 1 equal to x minus 2. All right, next, we want to square both sides. We have the square root of 2x minus 1, so we're going to square both sides, which will make the square root cancel on the left, leaving us with just 2x minus 1, and then x minus 2 squared on the right side. All right. So don't forget, when dealing with x minus 2 squared over here on the right, you cannot just square your terms like that. You're squaring the quantity. So that's what I did over here. X minus 2 times x minus 2. Erase some of this other stuff first. All right. So we have 2x minus 1 equal to x minus 2 squared. So you have x minus 2 times x minus 2. Fold that out. That'll give you x squared minus 4x plus 4. All right, so now we want to solve the quadratic equation. Do so by subtracting 2x and adding 1 so that they cancel on one side. So that'll leave us with x squared minus 6x plus 5 equal to 0.
Could you explain step number 3 again? There's a lot going on right there.
Well, we FOIL this out, and that's what this was. X minus 2 times x minus 2. And when you FOIL that out, that'll give you x squared minus 4x plus 4. And so this is what you have as a result. And now you can set one side equal to 0. And so that's why we subtract 2x and add 1 to both sides so that they'll cancel out on this left side, leaving you with just 0. And then over here, that's, that result, x squared minus 6x plus 5.
I understand. Thank you.
Mm-hmm. And always feel free, everybody feel free to ask again. If you need me to re-explain, it's not a problem. Just let me know. Make sure everybody's clear before we go on to another step. Make sure everybody's with us. All right. And remember, we can't go any further in our quadratic solving until we set that one side equal to 0. So that's why we had to do minus 2x and a plus 1. So once you factor that, now remember, if you don't want to factor, you can always use your quadratic formula. Either way, you will still get the same results. Set each part equal to 0. X minus 5 equal to 0 will give you 5. X minus 1 equal to 0 will give you 1 as a solution. Any questions before we do our check? So we have to check these out to make sure that they work. Even if you've done them correctly, when going throughout this process, it's a possibility that your solution or solutions may not work. So you have to check them out. So when you plug them back into your original equation, remember our original equation was the square root of x minus 1 plus 2 equal to x. So you plug in 5 wherever you see x. And you see we have the square root of 2 times 5 minus 1 plus 2 equal to 5. Square root of 10 minus 1, square root of 9. That's 3. And 3 plus 2 is equal to 5, so that checks out. And then when you plug in 1, you do the same thing. Then you have 2 times 1 minus 1 under the radical. 2 minus 1 is 1. Square root of 1 is 1. And that's 1 plus 2, which is 3. And you see 3 equal to 1. Does not work. So, let's see if, oh, let me do that. Let me go back. There you go. So x equal to 5 is our only solution. All right. questions on that?
Could you scroll back up a little for me?
All right. How far?
A little more right there. Can you scroll back down?
Hold on, there's two different voices. Or the same person. So that means we're good with that part. All right. So questions on that process before we do it again. Make sure we're good. All right. All right, go to the next one. Let's go. All right. So our next one, square root of 3x plus 1 minus square root of x plus 4 equal to 1. So notice this time we have two radicals involved. All right. So notice that we have two different radicals. We can move either one of the radicals. It doesn't matter. We just need to figure out which one we want to isolate. Remember, the first step is to get one of the radicals on one side by itself. The easiest one to move would be this one, the x minus with a negative square root of x plus 4. Because it's negative, what we would do is add the square root of x plus 4 to both sides and have this result. So now we have this one by itself, the square root of 3x plus 1. And then on the right side, we have the square root of x plus 4 plus 1. Make sure you're careful with the extension of your radical. Notice the radical does not extend over the plus 1, just the square root of x plus 4. And then the plus 1 is not under that radical. All right. So next step, we want to raise both sides to the power of the index of the radical. So we know that this is the square root, so that means we need to square both sides. And that square and square root on the left will cancel out, leaving you with just 3x plus 1. And then on the right, we have the square root of x plus 4 plus 1 squared. All right. So now we have to follow the same procedure as we did before. You cannot just, once again, you cannot just take this square and apply it to individual pieces because of that plus sign. You have to expand it out. So let me erase some of this stuff. So we're going to do FOIL, which is the square root of x plus 4 times the square root of x plus 4. Square root of x plus 4 times 1. 1 times the square root of x plus 4. 1 times 1. And so that's the result. And don't forget, whenever you multiply radicals, if you had the square root of 2 times the square root of 5, that's the square root of 10. You just multiply what's under the radicals. So that's what we did here when we did the square root of x plus 4 times the square root of x plus 4. That's x plus 4 times x plus 4, which gave us x plus 4 squared under the radical. So that's what happened there. And then, 1 times square root of x plus 4 is this one. And then 1 times square root of x plus 4 is this one. And then 1 times 1 in the back. So before we go any further, questions on the expansion or the binomial distribution? All right, questions before we go further? So now, when we go to simplify, this square and square root will cancel, leaving us with just this x plus 4. Also, we have like terms, and there's a 1 that's in front, so I can add both of these, and that'll give me 2 square root of x plus 4. All right, make sure we're okay with that. And then I can add the 4 and the 1 and make that a 5. So that's how we got the 5 back here. So all of that simplified would be x plus 2 square root of x plus 4 plus 5. Any questions?
Where did you get the 2 1s from that you put in front of the radicals?
It's already assumed that you know that there's a 1 there. Just like when you have the variable x, they assume you know there's a 1 in front of it. Same thing if you have a, they assume you know there's a 1 in front of a. So whenever you have a term or an expression, they assume you know there's a 1 in front of it. Yeah. And so, adding both of those expressions together is how we got the 2 in front of this expression right here.
Also, did you add the 4 inside of the radical to the 1 on the outside to get 5?
Right here, the radical and the square cancels out, leaving you with just x plus 4. And so this 4 right here is what I added to the 1.
Okay.
All right. So that's a good question because this 4 under the radical cannot touch that 1. So the only way I could do it is if there was no radical involved. And so that's what happened right here. All right. So going to the next step, we have to isolate the radical again. We have a radical still involved. Don't forget when you go back to your steps. Oh, where are steps at? Um, Here it says solve the equation, blah, blah, blah. It says repeat steps 1 and 2 if a radical still exists in step 3. So we got to go repeat steps 1 and 2. All right, I moved past it. Yep, isolate the radical again. So what we need to do, let me erase this so we can walk through it. We need to get this by itself. So we're going to subtract x and subtract 5 from both sides. X is cancel, 5's cancel. And that leaves us with 2x minus 4 equal to 2 square root of x plus 4. All right. So now, if we want to get this radical, oh, wrong button. Now, if we want to get this radical off, we need to, once again, raise both sides to the power of 2. So we want to square both sides. All right, so what's going to happen here for us is that, and I didn't mention this here, like at this moment, at this point, because I have a 2 that's involved with each term, I could have divided by 2 to simplify our equation, but I want to emphasize a point that you more than likely will come across in the next step. But if I divided by 2, I wouldn't see it. So for those of you who saw that, then you always can do that, but I need to emphasize something here in the next step. And so when we square both sides, I'm going to have to expand this side out, which is 2x minus 4 times 2x minus 4. We'll do that in a second. Well, this square here needs to go to, and needs to be applied to the square root and to the 2 on the outside separately. So that means the square root will cancel, leaving you with just x plus 4, and then 2 squared is 4. So right here is the result of the squaring. 2x minus 4 times 2x minus 4, and then 4 times the x plus 4. Do your distribution, and we can distribute here as well, and you get these 2 results. All right. Questions? Any questions? So,
Can you talk through the FOIL one more time?
2x times 2x, and then 2x times negative 4, and negative 4 times 2x, and negative 4 times negative 4. So that's how we get 4x squared minus 4x, 4x squared minus 8x 8x plus 16. And then you add your Middle terms is negative 8x, and negative 8x will give you negative 16x. Yep, so you would distribute the 2x and then distribute the negative 4 into the other parentheses. And the other one is 4 times x and then 4 times 4. So it'd be 4x plus 16. All right, any other questions? All right, so now once again, we have a quadratic equation. We want to set one side equal to 0. So we're minus 4x minus 16. On the right side, 4x is cancel and the 16 cancel. Also, we notice that 16 cancels on the left as well and gives us the result of 4x squared minus 20x equal to 0. All right. So now we factored out 4x. Factor out 4x. That would be 4x times x minus 5. And set each part equal to 0. 4x equal to 0, x minus 5 equal to 0, and of course the way to solve is divide by 4. Here we'll add 5. And those will be our two solutions. All right, questions before we check? All right, are we okay? So here's the check, just plugging in 0 into the original equation, plugging in 5 into the original equation. And you see that 0 didn't work for us, but the 5 did, so it's our only solution. All right. Any questions? Any questions? All right. All right, so let's look at radical equations in the form of x to the m over n equal to k. So if m is even, in other words, your top number of your exponent, so we're going to have an exponent that's a fraction that's on our variable. And so if m is even, this is going to be the result. First of all, you raise both sides to the reciprocal. So we had m over n, and we raise both sides to the n over m. And so we also have plus or minus involved. So we should get two solutions when m is even. Should get two solutions when m is even. That plus or minus should be involved. And then when your top number is odd, when m is odd, you only get one solution. You're still going to follow the same process. You raise both sides to the power of the reciprocated fraction, but you only have one solution. So once again, if m is even, that top number is even, you're going to have two solutions because you're going to do plus or minus. But if it's odd, you only have one solution. And of course, we'll go through a couple examples. Want to just make sure you have a chance to write down the process. All right, can I scroll up? Okay, so just making sure I emphasize what it means for us to have a exponent for, a fraction for an exponent. Always hold true to the idea that, did I write it down? No, I didn't. That your numerator is your power. And your denominator is your radical or your root. And it doesn't matter which order you do it in, as long as you hold true to that thought process. So I have 8 to the 2/3 power, or to the exponent of 2/3, whichever way you want to say it. I'm going to either take the cube root of 8 and then square it, or square 8 and take the cube root of that. So in the first one, I took the cube root of 8, which was 2. Then I squared it. 2 squared is 4. In the second one, I decided to square 8 first, which is 64. Then took the cube root of 64, which is still 4. So either way, you'll come up with the answer of 4. So it doesn't matter which order you're doing it in, unless you're doing it by, in your head or in your mind, and which familiar numbers and familiar way to do it would be more beneficial to you. But if you're doing it in the calculator, most definitely doesn't matter. But you just have to hold true to the idea that the bottom number is going to be your root, the index of your radical, and the top number is going to be your power. And like I said, it doesn't matter which order you do it in, you'll still come up with the same result. All right, questions on that relationship before we actually do a problem? All right. So first one we have is 3x to the third 3/4 power minus 81 is equal to 0. So first thing we want to do is isolate x to the 3/4. So you want to get that by itself. So we'll add 81 to both sides. They cancel. Then we'll divide both sides by 3. And that'll give us x to the 3/4 equal to 27. So before we go past this, make sure we're okay. All right. Any questions? So now if you look at the process, what we need to do is take the inverse or the reciprocal of 3/4 and raise that to both sides. So I'm going to raise this to the 4/3 power and do the same thing here. So the reason why that is important is because whenever you're raising the power to a power, you're multiplying your exponents, and that's what ends up happening here. 3/4 times 4/3 is 12 over 12, which is just 1. So that gives us just x on this left side. And so now applying the 4/3, the 27 to the 4/3 power, I'm going to take the cube root of 27, raised to the 4th power. Remember, your numerator is your power, denominator is your root. Cube root of 27 is 3. 3 to the 4th power is 81. So that's your solution. All right, question before we do another one. So remember, this one started off with an odd power in the numerator. The next one has an even power in the numerator. Trying to erase some of this stuff off. So once again, well, in this case, let's go there. In this case, we have x to the 2/3 power minus 3/4 equal to negative 1/2. All right. Want to isolate x to the 2/3. So we'll add 3/4 to both sides. All right. Don't forget, whenever adding and subtracting fractions, you need a common denominator. So we need to multiply top and bottom here by 2 in order to turn it into negative 2/4, turn it into a fraction that has a denominator of 4. All right, so adding those together will give us 1/4. So now we have x to the 2/3 equal to 1/4. Before we go any further, any questions? All right, so now we do the same thing that we did before. Raise both sides to the reciprocal of that fraction. So we had 2/3 as a fraction. Oh, all right, we back, right? Something happened with my share. Okay. So raise both sides to the 3/2. We had 2/3 initially, so we'll take both sides to the 3/2 so that this 2/3 and 3/2 will cancel. Leave me with just x. And also don't forget, we had an even. We started out with an even numerator. So I need to use plus or minus because that square is going to be at the bottom, which would be a square root. So you see what the result is. We're going to take the square root of 1/4 and we're going to cube it. So once again, this is the power and this is the radical of the root. That's why we did the square root of 1/4 and then we raised it to the 3rd power. So then the square root of 1/4 is 1/2. And then if you cube 1/2, that'll be 1/8. So we have plus or minus 1/8. All right. Questions. Let's see, we have, hold on 1 second, got that one, that one. Let's see, do I want to go here? Let's do two more and we'll be done for today. So this next type of equation is having the equation in quadratic form. Looking at our original equation right here, we have x to the fourth minus 8x squared minus 9 equal to 0. All right, so what does it mean for an equation to be in quadratic form? We know before we would have something like a squared plus, let's say 5a minus 7, something like that, wherein you have your a right here, and then this is a squared. So when you have that type of situation like we do in this case we have x squared, and then we have x squared being squared. So whenever you have your term here, and then in the front is that term being squared, you have an equation that's in quadratic form. Okay. So once again, we have x squared right here, and then in the front we have x squared squared. So what we can do, if we want to simplify the equation, we can let u be equal to x squared and rewrite the equation as just u squared minus 8u minus 9 equal to 0. So we use the fact that it was in a quadratic form to rewrite the equation to make it easier for us to solve. And now we can solve this. Once again, I decided to factor. If you didn't want to factor and just use the quadratic formula, you could do that. So u minus 9 equal to 0, u plus 1 equal to 0. And that gives us u equal to 9 and u equal to negative 1. Questions? All right, so we're not done because we didn't start off with u. U was x squared. So we'll put the square back in. So that'll be x squared equal to 9, x squared equal to negative 1. And now to solve, we'll take the square root of both sides. Square root and square cancels on the left in both cases. And don't forget, whenever you take the square root of both sides, you have to use the square root property. So that'll be plus or minus 3 and plus or minus I. Don't forget the square root of negative 1 is I. So you have two real solutions and two imaginary solutions. Questions? Any questions? Before we do one more. All right. Questions before we go to the next one? All right, so the next one takes on the same quadratic form. We have 5x to the 2/3 plus 11x to the 1/3 plus 2 equal to 0. And so it takes on the quadratic form because we have x to the 1/3 and then x to the 1/3 squared in the first term. All right. So that means just like we did before, we let u be equal to x squared. This time we'll let u be equal to x to the 1/3. So now we have 5u squared plus 11u plus 2 equal to 0. All right. Once again, I decided to factor 5u plus 1, u plus 2. Once again, just a reminder, you can use the quadratic formula. Get the same two results. So 5u plus 1 equal to 0 gives you u equal to negative 1 over 5. U plus 2 gives you u equal to negative 2. All right. Any questions? So once again, u is not what we started off with. U is equal to 1/3, x to the 1/3, excuse me. So if you were to put x to the 1/3 back in for u, that's x to the 1/3 equal to negative 1/5, and x to the 1/3 equal to negative 2. And over here, I was just reminding you that x to the 1/3 is the same thing as the cube root of x. So those are the same thing. So now in order to solve for x, since 1/3, x to the 1/3 is the same thing as a cube root of x, you can just cube both sides. Put it up there right there. Well, yep, cube both sides. Cube root and cube will cancel on the left in both cases. And negative 1/5 cubed is negative 1 over 125, and negative 2 cubed is negative 8. Those are your two solutions. All right, questions? Any questions? All right. So if you guys are good, I am good. We can start right here. Next class, we'll finish off 1.6 with absolute value equations. And I think that's the only thing in this section left. Yep. We'll go to the next section. But outside of that, I will see you guys on next class. Don't forget to shoot me emails if you have any questions. And have a good one.
Thank you too.
All right, take care.
Have a good day.
You do the same. Thank you.
I have a question, but I have to pull up the work.
See ya.
All right, take care. Take care. All right, you said you had a question?